Today we will see registers and how registers are working using digital circuits. So a register is a very important digital building block, and the purpose of a register is to store binary information. So this registers plays important role in operations like multiplication, division, complementation, and other things. So registers are generally consisting of flip-flops. So the binary numbers can be stored by using a flip-flop. So each flip-flop can store one binary number. So if you wanted to store an 8-bit binary number, you required 8 flip-flops. So this using these flip-flops you can input the numbers, and also you can use flip-flops for shifting these numbers. So generally register used for storing and shifting of the binary numbers are called shift registers. Okay, so shifting can be done in two different ways: serial shifting and parallel shifting. In serial shifting, we are entering numbers one by one, so from either from the LSB, least significant bit, or from MSB. So one bit at a time, input one number, then after next cycle you input second number, like that it will be serially inputting. In parallel shifting, you can simultaneously input all the required inputs. Okay, so the uses of shift registers are to store data, or for to generating to shifting the data to left or right shifting, depending upon the requirement, and also it can be used to produce a delay. So by using some clock pulses, you can control the timing between different signals. So you can introduce delay, you can either you can and the fourth one, you can convert it by serial or parallel. Serial data can be converted into parallel data, and vice versa. So this figure represents how we are doing serial inputting and parallel inputting. In first case, data is inputted one by one, serially inputting data and taking out data serially. In the second case, in figure B, serial input and parallel output. So input will be one by one, and the output will be taken together. And the third one is parallel input and serial output. And the last case, it's parallel input and parallel output. Here we will be discussing about two things: serial input, serial output, and serial input and parallel out. So first case is serial in, serial out. SISO, it is called SISO, serial in, serial out. So we can implement this serial input shift registers by using JK flip-flop, RS flip-flop, or a D flip-flop. In the figure, in our example, we are taking a D flip-flop to implement a SISO circuit. So this let us consider a 4-in-4 data flip-flop. 4 binary numbers need to be shifted, so we are using 4 flip-flops. 4 D flip-flops are used, and they are D flip-flops have only one input, so other input are tied together, so only one input, and they are controlled by the single clocks. Same clock is applied to all the 4 flip-flops. So the transfer is taking from the first the serial input. This serial input, here we will be giving input, and that will be generating an output corresponding to the first flip-flop, that is connected to the input of the second flip-flop, and so on. So let us consider the case of, say, suppose I wanted to shift a data. That's this number 1101 is the number which I wanted to transfer from one place to another, one point to another. So let us see how we are implement this. First case is we will clear it by clearing signal. It is not shown in this figure. There will be one more line that's called a clear signal. So if you give a high to the clear signal, it will clear all the data stored in the flip-flop. So if suppose we cleared it, initially we cleared it, so the data stored is 000. Now on the next clock pulse, what we do is we are setting the value, we are inputting the value corresponding to the least significant number, that is this one. This LSB is shifted in. Okay, so this LSB is shifted in, which means the data stored will be 100. That is the output of the first flip flop will be, this will be output of the first flip flop will be 1, another initially it was 0 0 0 0, all the outputs are 0, so then we give a 1 here, so this become 1 and all other become 0 0. This is 1, this will be 0, and this will be 0, and this will be 0. Now on next pulse what we do is we input the second number. So in the second number, that will be a 0, so this 0 will go here. So what means this 1 at the output of the first flip flop will given as input to the second, so the output of the second will be changed to 1, because this is 1, this will be output will be 1. So the next case output will be 0 1 0 0. Okay, 0 1 0 0, 0 1 0 0. Okay, so the data stored is 0 1 0 0. Now next pulse you will input the third number, that is this third one, this become 1 0 1 0. Now this process continues until you input all the numbers. So for the next pulse you give 1 0 1 0. You input one more 1, so that means the data stored will be 1 0 1 1 0 1. So this completes the circuits. For you can see from this here, so initially you have a 0 0 0. Now on the next pulse this 0 will go out, this 0 will go out, and this data output of this S will go to T, and the R will go to 0, and Q will go to 0, and this is empty, that will be your input. This is R1. On the second pulse, this output, the T output will go out, and S will come here, R will come to S, and Q will go to R. And so this is continued for some pulses. Say after the fourth pulse you are stored your data, whatever your required data is 1101 is stored. Okay, this is how we store the data by using serial inputting. Now in order to get the output, it is serial in serial out, the output is not ready. So in order to get the output after the fourth pulse you apply 3 more pulses. So the each output, this output will be your 1 for on the after third fourth pulse this 1 will go out, and fifth pulse this 0 will come here, this will be coming out. Sixth pulse this 1 will come here and it will be coming out, and the seventh pulse will take this out, this number, each time one number will be shifted to the right. So finally after the seventh pulse you will get your output. So this is 1 0 1 1. This is how a serial in serial out is working. So the disadvantage is that after inputting all the data numbers you cannot take the data out, because to get the data out you require a few more pulses. So in this case 3 more pulses are required to get the output. This problem can be eliminated by using a serial in parallel out circuit. So this is a serial in parallel out circuit. The circuit is exactly same, only thing is that your output is taken from each of the flip flops are connected to the output. I mean, we are taking an output from each of the flip flops. So the remaining things are same. Suppose I am inputting the same number, same example 1101, the process is same. So each time you are shifting one number, and finally after the fourth pulse what will happen, see the each QA QB QC output are exactly your input number. So this is parallel serial in parallel out. The other explanations are exactly same as the previous one, only difference is that you are taking the output parallelly from each of the flip flops. Okay, so this is how serial in and serial out and serial in parallel out circuit works.